Ladies and gentlemen, I'd like to introduce our next speaker. This is Dr. John Bates, who is current CEO of Test Plant. Brief history on John. He was the first chairman of the Board of Patrons, which is the steering committee for Smart IoT, former CMO of Software AG, former CEO of Plat One, is acquired by SAP, former Cambridge Don, and all around very, very decent guy. So I'd like you to very warmly welcome him to the stage.
So, good day everybody. John Bates, and John kindly introduced me. I sound wonderful, I'm not as nice as that really. But in fact, I'm the CEO of Test Plant. We're in the process of changing our name to our product line, Eggplant. So you're the first to know. CEO of Eggplant, and I'm going to talk today about how testing automation and monitoring applied to IoT is helping to be able to see if IoT apps are actually meeting and exceeding their business goals. So let's start off with something which I thought might be, this is quite dull. The testing market. It's evolved from testing monolithic applications through the evolution of the web to mobile applications and gained in complexity. You've also have this world of custom devices. So before IoT, if you're going to do anything with hardware like point of sale devices or tracking things, it was in the custom world. But now suddenly, the evolution of the Internet of Things has meant that a lot of these things have come together to create what people are calling a digital experience. So it's a mobile front end, it's probably cloud back-ended, it's got things at the edge, tracking devices, its custom devices are no longer custom, everything is connected. So the world has really evolved. And testing automation, frankly, hasn't. It hasn't changed for 30 years. So if you look at the architectures and how they've evolved from that monolithic architecture we talked to, we're now in a really complex world. Testing automation technologies has been about looking at the code objects and saying, is the right value in the right place? Have we tested this? But actually now it's much more complex because in many cases you don't even own the code. IoT apps are made up of cloud-based microservices with APIs, edge-based microservices running on devices at the edge in the cloud with typically a mobile front end if there's a user experience. So it could be something like tracking tires on a trucking fleet and then visualizing big data analytics to say this truck is wasting fuel or this truck is off course and so on and so forth. Also, the success really has moved from being, have we tested it, to is this application actually meeting its business goals? So now, this evolution of testing has gone from quality assurance to a world of continuous business assurance, in which whether you're delighting your customers means whether you're succeeding, or whether you're actually hitting your business goals of revenue, of profitability, of reduced cost, or whatever it is you're trying to achieve from your IoT application. So this has to be taken into account. So an example, Cerner, they're in the hospital automation space, large public company headquartered in the United States in Kansas City, customer of ours. They obviously automate hospital processes, connecting things like premature babies to a whole load of equipment to make sure they're okay, or automating the process of electronic medical record distribution, so on and so forth. How do they measure their success? Do they measure it by, have we tested it, does it work? No. They measure it and they have a big dashboard in their lobby that says how many lives have we saved today. That's how they measure it. For example, detecting sepsis and preventing it, or detecting some kind of vital sign issue and preventing a casualty. Similarly, take somebody like Walmart, another customer of ours. They've IoT enabled their entire supply chain. They track in a very complex way at their point of sale, in their warehouses, and their online presence. They're an omni-channel organization. They are measuring their success, and their big bet is that the real world is going to intersect with the online world to give them an ultimate advantage against somebody like Amazon, who right now they probably would say they're behind significantly too. But that's how they measure themselves. How are we doing against outperforming Amazon? That's how they track their IoT world. And then somebody like Pizza Hut. Are we delighting our customers on our online experience? Are we delivering, once it goes out into our delivery network, the experience, the right toppings? Is the experience online and then delivery out through the IoT-enabled delivery network actually delighting our customers? So some real examples of how tracking business success and customer delight is actually happening. So getting back to how do you actually track this, going from testing into continuous testing or monitoring? So this area of test automation is evolving, and we're at a point now where we're saying we need to apply artificial intelligence and analytics in the same way as we've done in many other areas to improve the performance of the human tester. So a human needs to evolve to have co-processors powered by AI to be able to understand and test this IoT era application. And we'll look at this in more detail. If you look at this continuous delivery framework you have in the IoT era, where you're going from very rapidly releasing new products, develop, build, test, deploy, release, test often falls by the wayside. In fact, if you look at the data from a recent survey of 400 major organizations, pretty much all developers agree that the requirements for innovation in the IoT era have radically increased. But most QA teams say they can't keep up with the amount of time they have to test these complex architectures. And in fact, 40% of organizations admitted to releasing software that wasn't tested at all, which is absolutely remarkable. If you look at the testing process, when you talk about automating tests in IoT, most organizations would think that means writing test scripts and then running them every time you do a release of a new product. But actually, testing goes a long way from defining the objectives, building the tests, setting up the environment, executing the tests, analyzing the results, and learning from that. And in fact, really, if you want to do more in that time available, you should automate the entire process, end to end. You should automate the writing of tests, you should automate the running of tests, and you should automate the learning from the test results and feeding that back in. And I'll show you some examples. So how can you apply AI to this process of writing tests in the Internet of Things era? Well, first of all, you have to be able to take in a whole lot of data about the system that you're running. So traditional testing, you would say, these are the paths of the application I want to test. But then with an AI-driven world, you can test, for example, in let's take a battlefield type scenario where somebody's going to be under stress, maybe under fire, using a command and control application, or a healthcare type scenario where somebody's going to be under stress in an ER, emergency room. You're going to behave differently to how the tester originally designed or specified the application. So maybe you want to explore permutations around those pathways that were specified. But similarly, maybe you also want to explore white space that was never designed to be tested. And you also might want to prioritize pieces of code that have changed, or focus on developers who are very known to write buggier code than other developers. You may hear in the IoT world the digital twin, the concept of a digital twin, which is a digitized version of a real-world object that you can apply, you can take readings from, and you can apply operations to. If you consider an AI model of an application, this is really like a test digital twin. You should be able to move through states of an application. Each state should have properties and settings that you can change. These might be screens on a mobile application that you move through. They might be parts of a process in an industrial application. And at each stage you can set properties and change properties, and they might move you to other states in the application. If you have a digital twin that's actually a model of the application, you can reason about it. You can apply AI algorithms and analytics to it, as opposed to having some test script which bears no relationship to the IoT app at all. And in fact, the idea is that in traditional automation, the number of scripts you get are created linearly through programming. You put in the same amount of effort and you gradually get more and more results. But in this AI-driven world, you would put in some effort to start with, but then along with the scripts, along with the journeys that you've defined through the IoT app, it would also write other journeys for you to explore uncharted area and to actually test this. So you would get a lot more results in response. In fact, millions as opposed to maybe hundreds of cases that have been generated by an AI algorithm. So that's writing the scripts, but then running them in the IoT era, we talked about microservices, we talked about front ends, we talked about underlying objects. Well, first of all, the user experience in IoT is absolutely critical, testing through the eyes of the user. So you really need to have the concept of, again, an artificially intelligent user who can use the application as a user would, driven by the AI, if you like, test script. So you need to be able to take control of any mobile device, any point of sale device, any edge device, any kind of thing, even something like a voice-driven interface like an Amazon Alexa. You need to be able to control this, and I'll show you a few examples in a minute. You really need to be able to also tap into APIs, because an IoT application, you probably want to drive it first of all as if the user's using it, but you might want to force the microservices at the cloud and at the edge to actually behave in a certain way to see if the right data is flowing from the edge to the cloud to the underlying code objects to the front end, if it's delivering data to a user. So you have to be able to basically take control of a slice through that IoT application. And an example is NASA, another organization that we've been working through, their Orion space vehicle, the goal of which is to get humans to Mars within the next decade and return them safely. So they obviously measure the success of this by the mission being completed. The architecture of this, for the first time in any space vehicle, there'll be no paper manuals on board this spacecraft. This will be fully controlled by a glass cockpit, a single pane of glass, if you like, that the crew interact with. But yet there are sensors tracking things in space, in the vehicle, communications with mission control. So you've got essentially data coming in, a microservices, redundant microservices architecture feeding through to a single user interface view. So in order to test this kind of architecture properly, you need to tap into those APIs to check that the data is coming in the right way, the underlying code objects, and what's appearing from the user's point of view. And if they don't match, then you're in danger. You want to make sure that the user is getting the reflection of the IoT data in the right way. That's the only reason that NASA was working with us, because we're the only organization with our architecture that can deliver that. So I'll give you a few examples now. I'm going to show you 3 quick videos along this topic, because it's not just about software. In testing and monitoring IoT deployments, you often need to use IoT itself. Connected robots, you need to be able to use voice recognition and voice control, and a number of other things. We'll start off with Walmart. I was lucky enough to go to Walmart's point of sale testing center. We run this enormous It's like the biggest Asda you can imagine, full of all of Walmart's self-checkouts, checkouts of different varieties from different stores around the world. Their gas pumps, their petrol pumps, and everything else where you would interact with a human. And everything is automated through our Eggplant software where possible, but sometimes there's things like point of sale devices where you need to take control through a robot, or where you need some special kind of hardware that would select a credit card to shove in. And I'm going to show you a quick example. Here you can see, self-checkouts. There's Gareth checking stuff out, petrol pumps, so on, a point of sale device. I'll show you a quick video that demonstrates how you might automate using IoT to automate the process of checking out. So you can see here this robot is going to sign its name and check out as orchestrated, and the right credit card was inserted into this point of sale device. So it's a question of software and hardware architectures connecting to APIs, connecting to screens, and then also driving robots where people can't automate it themselves. Another aspect of this is the modern technology for fingerprint recognition, face recognition, and driving that in coordination with software automation. So let's say you want to have mobile applications that really wake up in response to fingerprints rather than simulation. Here's an example of, this is a fingerprint robot. We haven't cut off someone's finger. It's got a print of someone's fingerprint there, and you'll see as this script gets to the right point, so this fingerprint will unlock the phone. And we've got a similar thing with faces where it can bring up a three-dimensional face and unlock the phone in the same way. So this is where you really want to see if in the real world that something really works in that way rather than just simulating it. You can see this is going to unlock the phone again, there you go, and so on and so forth. So little robots all interconnected to drive this kind of behavior. And then if we look at the integration in IoT of audio-driven interfaces and speech recognition, IoT is really these sort of mashup applications where your phone told your Fitbit, that told your Nest, that told your Sonos, that told me that you owe your wife an apology, and shall I buy those roses for you? But joking aside, I'll give you an example. This is really the way apps are in the IoT space. And this, if we can turn the volume up of this, you'll be able to hear, this is going to mash up driving a speech recognition type system or a voice-driven system with looking at the behavior of apps online.
Alexa, can you tell me the share price of Amazon?
As of 12:13 p.m. Eastern, Amazon.com traded at $1,150.02, up 0.74% since previous close.
So you can see we're driving speech there, we're recognizing the output of that, but then we're also correlating that with, and comparing that, the share price of Amazon in this case, as a little example, of is that actually the share price of Amazon if we look it up on a real-time stock application, which is also being driven. So you're comparing the output of a speech to something that's on an application that might be coming through an IoT API, for example. In this case, it's just coming from the stock market. It failed because the values were different, because Alexa was giving you the closing price from yesterday and this was the real-time price. But this is just an example. So you can see deploying mashups of IoT, robots, and so on in amongst this monitoring is really important. So just to bring all this together and talk about how you make sure your apps are meeting their business goals, we've really talked about how a model is a digital twin of an application, how you can apply AI to this, and we have a product called Eggplant Ai that we use to auto-generate scripts that can then be run with a Fusion engine across IoT apps, APIs, edge, cloud, front end, underlying objects, to give you analytics which will say this is how your application will perform against your key business objectives if you were to release it now. So that's somewhat about the development. But then there's this concept also about shift right. Often you have to release your app. You might want to release a prototype. You might want to release something quickly. So there's this concept of shifting right. Actually releasing your app and then continuing to test in production by monitoring the way your users are intersecting with it or the way it's intersecting with its hardware devices. Monitoring what it's actually doing through a user's perspective with synthetic monitoring or through a hardware perspective, or seeing how the users are really doing it. And continuing to monitor how you're doing in real time against those key business objectives. Are you beating Amazon? Are you saving lives? And so on and so forth. And if you find a problem with this, to be able to then link that back to your testing and to say, okay, if I link that back and focus testing on that particular user journey where I'm not getting the results that I want, so people are not putting things in their basket and checking out in my store with their augmented reality experience, it might be because there's a usability problem. Blue on red text and no one can read it. It might be there's a functionality problem. When we get above 1,000 concurrent users, it crashes. It might be there's a performance problem. Millennials are getting bored waiting 3 seconds for the response time. You can find that out and then say to the business, if you fix this problem, you can address this revenue shortcoming and actually increase your revenue performance, increase the number of lives you've saved by addressing this problem, increase whatever it is that's your business goal. So this was really the message of bringing together development, operations in that DevOps world, but also the business. Can you provide a predictive analytics and continuous analytics view of how we're doing against our business goals and link it back into development and say, if you fix this problem where we found it, you can improve the performance of your IoT application and meet and exceed your business goals. So that was really the message. Pace of this kind of IoT era application is putting a lot of strain on traditional testing, monitoring, needs a completely new AI-driven approach. New architectures, mobile microservices, cloud and edge, radical departure. You need a new underlying automation capability, including through the eyes of the user, API testing, and bringing in hardware where necessary. And businesses measure the success of IoT apps based on business factors, not technology factors. So we need to start monitoring against those business factors, testing against them, and continuously testing against them. That's it for me. Happy to take any questions.
Dr. John Bates, I'm sure there is questions. Extremely interesting. How, just something very random, to go from test plant to eggplant. I've seen it on the website, that's already up there.
So Eggplant's the name of our product. So when I joined, I thought, oh, I don't know about this eggplant. But so we had Test Plant was the name of the company, but we're moving to do a lot more than testing.
Okay.
And in fact, everybody knows us in the world as Eggplant. Our customers, when I go and see them, they go, oh, you're from Eggplant. So we thought, okay, it's out there, it's a bit radical, it's modern, it's fresh, we'll be Eggplant.
That's great, we will spread the word.
Yeah.
So, any questions? Over here. Great. Introduce yourself.
First of all, great presentation, thank you.
Thank you, sir.
How do you integrate with the different devices? Do you provide like SDKs or something? For example, if you work with iPhone or Android or something, or how do you actually accomplish to get your testing code into these devices?
Yeah, so in fact, we're fairly agnostic in terms of testing. You can, through the user interface, sometimes there might be an agent on the device that can enable you to drive it, but on the whole, we use things like taking a remote view of the screen, for example, through something like VNC or remote desktoping capability, and then being able to use the ability to control that through the same kind of interface. So that's one of the ways in which you can be agnostic about any device. But you can, of course, have an agent on something that's a little more difficult to control that. But if you don't want to actually have an impact on that device, you want to try and minimize the footprint that you actually have on there. And many of these things support that ability, either through connecting to a host device, connected to the devices under test, or directly to be able to do a sort of remote controlling of it, if you like. And that's one of the key ways of doing it. Through APIs, obviously, you're connecting directly to those APIs through supporting those various protocols in your API layer. So it's different at the user interface level, different at the API level. And then for objects, you can connect through common API toolkits like Selenium, Appium, and things like that. If that makes sense. Thank you.
Any more questions? If not, I usually ask, did you ever get a very controversial or scary question? Or
did I ever get a very
else?
controversial question? I don't think so. I mean, I think probably your eggplant one was pretty,
was well, like,
pretty, yeah, well, what are you on about?
I'm always very curious about naming things. But you did mention that 40% of industry actually have said that they release products without testing.
That was a survey from 400, a recent survey actually this year from 400 organizations in the, in the US and the UK in things like telco, banking and finance, and major manufacturing, major industries. I'll tell you a really interesting statistic is in the Google App Store and the Apple App Store, only 4% of applications that are downloaded are actually used after the first month. So only 4%, and that's a great advertisement for user experience, because you have to capture people and win their hearts very quickly.
Yeah, many apps have the novelty thing, and then they don't actually add value, or the user interface is just not intuitive enough. So, yeah, I think we have to wrap up. Exactly. Thank you.
We're getting the hook.
So much. Yeah. We have. This is going very fast, and actually, I've been asked if everyone can leave through the back so that the next bunch can come from the front. How can people find you? How can people ask you more on Twitter?
Well, we're here. We've got a booth here. I'm giving out copies of my book, Thingalytics. If you'd like smart big data analytics and the Internet of Things combined, happy to sign it to half its value as well. So.
Wow, I'll take that, definitely. Thank you so much. See you next time.
Thank you very much. Cheers.